Another thing you may have noticed is that the address where say hello exists is exactly where nm and otool said it would be. So nm says that say hello is going to be at this address, and when we ran it was actually at that address. That's because when we use the debugger, it turns off address-based randomization, so that the addresses that nm predicts are the ones that are actually used when we run. That's less secure, but it's handy for debugging, and it also makes our job a little easier when we are trying to implement a buffer overflow attack ourselves, just to see how things work. But if I run this program directly using a.out, then it turns out that say hello was moving around every time. So there's one more thing we can do. I'm going to compile this with all the flags I had before, but in addition I will use fno PIE. PIE is position independent executable, but what this ends up meaning is turn off address-based randomization. So that now, not that you'll be able to see, but say hello stayed in the same place. Let's make it so we can see. Let's inside of main print the address of say hello. So it's likely to be, looks like I got it wrong here. Let's say printf. So every time I run it now, it's in the same place, whereas if I leave off fnopi, then every time I run it, it's in a slightly different place. The garbage output there is just because I hit Control D instead of typing something, and it turns out my program doesn't deal with an end-of-file input. In any case, that's all the tools that we need for dealing with executables to explore further making our own buffer overflow attack.